Hello, this is Akshara Priyadarshi from Karunya University. Register number UR15CS307. I'm doing this video to explain you about my 7th experiment in my data structure lab, which was about merge sort and quick sort. So I'm starting with the quick sort. I had to do this program in two different program sorts. So let's see. First, starting with the quick sort. I'm starting with hash include IOStream. As you all know, it contains all the standard library functions, and also using namespace std, which contains all the standard library functions like cout and cin of C++, and then I'm declaring few global variables like lu, ij, and n, which are used later in the quicksort functions. And then this is the declaration of quicksort function with a pointer variable integer and integer. I'll show you. These are all done here. um, I'll first explain you about the quick function. Okay, so this is quick sort function. Here, as we declared, this is the pointer. It is array, and then this is L. In we are taking as integer, which is lower part of the array, and then this is U, which is upper part of the array. I'll show you how. Then we are declaring few variables inside this function like p and temp. Okay, if L is less than U, that means whenever we are put okay, I'll show you in main function. Enter the number of elements will be short. That means how what should be the size of your array. Okay, then this n will be n will become the size of the array, and according to this we have to input the values in the array. This will be stored in a. Enter the elements. Okay, so this from here we are storing it in a. Now here we are initializing L, which is low, which was lower, as is equals to 0, and U equals to n minus 1, that is maximum minus 1. So quick, like all these which we got here, we are passing as argument to this function, and then sorted elements will show sorted elements by calling here. Okay, let's go here, go back here. So we got the input of the array. We know L is equals to 0, which is lower address of the array, and this is U is equals to upper address of the array, which is n minus 1. So now, while lower is less than U, we are declaring p, I, and j as array of L, which is lower, then lower and upper. While I is less than j, that means again same thing. Then here we have to increase I till array of I is less than or equals to p or L, and I should be less than j. Again, while array of j, which is upper, is greater than p and I less than equals to j, then we have to decrease j. This is because while we are doing a quick sort, we are just choosing an element, and then all the we'll compare with the all the elements. The elements which are greater than that chosen element will be taken to the left side, and elements which are which are greater than the chosen element will be taken to the right side, and which are less than the chosen element will be taken to the left side. So automatically the position of the chosen element will be set. Again we'll choose some elements, and that is how we'll sort the array, and hence it will become in increasing order. So that is why we are increasing this address and we are decreasing this address. So I will show you now. Temp equals to a of I. We are just creating a temporary variable for swapping. Now when we have swapped, like a of I becomes a of j and a of j becomes a of I. After swapping, then temporary equals to, again we are sort of swapping with I and between j and L. We got the value here of array of j, and now array of j will be swapped with array of L. I told you, no, we are shifting the numbers. Now this is for going to the next line. We can remove this, no problem. And then again, starting with 0 till n minus 1, we have to print, right? So again we are calling these two for printing the rest of the numbers. We are shifting and then we'll print the array here. Our result will be printed over here. Wait, I'll just show you. I So I took the help of the Wikipedia to show you. Yes, you can see here we chose an element, then the elements greater than that element to the right side, elements less than that element to the left side, and then we are choosing, and then this is how it's sorting. It's making an increasing order. Now it will go here, choosing, and then this is how sorted array works. I mean quick sort. So let's run the program and see whether it's correct or not. It's coming. I'm sorry. Yeah. Enter the number of elements of sorted array. Let's do 4. We Okay, fine. Now enter the element. Enter the element. Uh, so some random elements. Okay, 21, 13, 53, 34, 12. So as you can see, it has sorted it in 12, 13, 21, 34, like in increasing order. So as we have programmed. Now let's see for merge sort. Is nothing but it will just take the array elements, and then it will divide the array into two, again divide those two parts in two parts, and then it will split until all the blocks have become single blocks, and then it will compare with one of the blocks, and then those two will be combined or merged. So it's basically splitting and merging back. I'll show you with this example over here. As you can see here, see, it will be something like this in any order, then it will be splitted into two, again into two, and then in single blocks. Okay, and then one of them then they'll be compared with their adjacent ones and merged. See, compared with the adjacent one and merged, again merged and merged. So they'll be compared like this, and then one of them will be chosen, compared with the other one. See, one of them will be chosen, compared. Now those two were smaller, so that is why their place was over here. So this is how they're first dividing it and then merging it back. As you can see, it has been merged into two parts, as it was first splitted into two parts. Now they'll be compared, one block to one block of this one to all the block of this one. See, and if smaller, then it will come here, if larger, then it will go, it won't be affected. So this is how the merge sort works. Okay, now according to my program, I'm first declaring a function, and then in function I'm then again a function where I'm giving arguments, which will take arguments from the main function. Okay, so this is the array argument, which is a pointer, and then low and a high. Now we have we need a middle. So until low is less than high, we can find the middle of the array. Okay, so we are doing this so that all the blocks have split into one block. All blocks are separated basically. Now this was the separation one. Now we are merging it back. Now we'll take this. I've declared this array with the size. Maximum size is 50. Low, high, and mid. We are taking arguments as low, high, and mid and an array. So while I is less than mid and j is less than high, that means, see, I'm taking I equals to low and k equals to low and j equals to mid plus 1. Mid was nothing but high plus low by 2. So middle plus 1, low, low. So while we are doing this, that is I is less than equals to mid, then if array of first element is less than array of second, I mean element of second array is greater than element of first array, then we are again doing, we are sending this as the array address and then incrementing k plus plus and I plus plus. Similarly for the other part, I mean like if array element of first array is greater than element of second array, then we are doing this. Okay, that means c of k is then compared with a of j, not a of k. So here I is less than mid, c of k equals to a of I, k plus plus, I plus plus. Same thing, not same thing, but we are just bringing this loop for merging the slots by comparing. So now two parts will be compared and then final part will be compared. I mean merged, not compared, merged. So we are taking array maximum size as 20, then I and n. Enter the number of elements, then we are just putting whatever we want. I mean what size of array we want, then what are the elements that should be in the array, and then we'll call the merge sort to merge, I mean to sort the elements. Okay, and then it will print whatever we have got. And this is the second time if you want to do the same. We can even remove this part and no problem. So let's run the program. Yeah, see, yeah, 5. So as you can see, it has been sorted. So this is how my merge sort is working. So I hereby end my program. Thank you.